Alright, so what we're going to do is set this up for machining now. So we're going to move to a different workspace. So once it's all good to go, what we're going to do is we're going to go to design and we're going to go to manufacture. Now first thing we need to do is create a setup. So we make sure that we're on milling and we go to setup. And what this does is simulate the material that you're cutting your letter out of. So we need to make our origin point. So that's our 0 point. For this example, I'm going to be using just the center. And we just double check to make sure our X and Y are in the right location. We go over here, we go to stock, and we want to, relative just means that it, the material goes around the outside of your model. I want to increase side offset to at least 7mm, which is the width of our, larger than the width of your tool. And this is here is your minimum. And then what I'm going to do is I'm going to make 0 offset. So the top of my material is the top of my model. Now if you wanted to change this, you can change your origin point. You can put it into different locations around the top of your model. There might be some reasons why you do that. Typically it's the bottom left hand corner where you've got your X and Y wrapping around the corner, or your center. You just need to double check to make sure that the dot that's on the top of your stock is selected and not one down the bottom. Once you're happy with that, go OK. Now we're going to be doing a range of different toolpaths in here. Each toolpath that we have in here is a different operation, and the first one that we're going to do is adaptive clearing, and this here we use in order to be able to remove just as much material in here as possible. So we go and select a tool, we go into our school end mills, select our 6.35 2-flute downcut router bit. These these settings will be fine for what we're doing with plywood. Click on a geometry, and this is the stuff that we want to remove. So we're going to remove the material in this pocket here first. So we just need to select that surface, and then we can go OK, and then it will give us an outline of what these are doing. So at this present point, we can see these yellow lines, which are tool movement, and we can see the tool going into there, and we can see what that looks like by going simulate and seeing what the tool does. If your stock isn't on, you can click that button and turn it on, and then this slide down here. Speeds up and slows down. You can see some red showing up there. Okay, so that's showing that there's an error, and there's another window that's popped up saying there's something going wrong. So if you have a look at this as it's moving, this little color here, that's the length of our cutter, or the length of our flute, and you can see that this is actually going down into the material past that, and that's why that's throwing an error there. You can see all that red there. So what we're going to do is we're going to make some changes. So we're going to exit out of that, and in here, to get back into our toolpath, we double click, and we want to move across these tabs here. So the next thing that we want to do is we want to go to the passes tab. Now we want to cut all of it out, but we don't want to try and do it all at once. So what we're going to do is we're going to click on this box here, multiple depths, and to the maximum extent that we want to be working at is 6mm, and there might be different reasons why you go smaller than that. 6mm can be quite aggressive on some of our machines, but we'll leave it 6mm for this example. Stock to leave. Radial stock is stock that's on the side of the wall, and axial stock is at the bottom. If you hover over the window, it will give you a bit of an explanation about what is which. We don't want anything left on the floor, so we're going to go 0, and that will go all the way down, but leave some material on the wall to take off. Click OK. And you can see the blue lines are the cutting, and the yellow lines are the travel when not cutting. So we go into simulation again. We can speed that up to have a look. We haven't got any errors so far, so that's a plus. And we can preview all of the all of the toolpaths going. Now, if we slow that down, we can see that the tool is cutting, the machine is cutting, and then it raises up again and moves across, and then it goes down and cuts again. Now, doing those movements can take quite a long time, in the extent of cutting all of this out. So what we want to do is we want to change it to make things a little bit faster. So again, we go back into our toolpath, double clicking, we go back to passes, and we want to click on this thing here, which says both ways. So what that will allow us to do is the cutter will allow us to go forward and backwards. Click on OK. And you can see that those movements, or those yellow lines that were there before, are now not there. And if we go and do our simulation, press play, speed it up. See, our cut is now going forward and backwards. It's cutting both ways. And that there is a way to be able to be a little bit more time efficient. Now the next bit is this. We're going to focus on this little spiral here. What that does is it goes around and around, as you would have seen in the simulation, into the material. Now there could be reasons why that happens when we are using harder material like metal, but because we're using wood and the end mill acts kind of like a drill, we can actually just plunge into the material. So what we want to do is, in our linking tab down here under ramp type, see it's got a helix. We want to change that to plunge, and that will make that movement going into the material a lot faster. Click OK. Oh, wait till the toolpath is generated. Simulate. Missed it. Yeah, if I go play from here. You see a bit of a preview of everything going on. Oh, that's going a bit weird, so I'm going to start it again. Okay, right. So, pressing play, you can see that it just plunges into the material. Just loading. Instead of doing the helix pass, and then it starts going around and do its toolpath. Okay. Alright. Now the next thing that we're going to do is we're going to do our ledge. And the next toolpath we do is we just make sure that we've got our toolpath, our setup selected. And it should be pretty default. It should be called the 2D contour. But another way you can do is click on that little arrow, and we go like so. So for this, we're going to be machining this ledge. Okay. So we're going to be using the same tool. By default, it should just show up. And so with that, we move over to the geometry tab, and we want to click that path there. Okay. So if we go OK, just to see what happens, press on our simulation, press play, we can see that it's going up against that wall, which is what we want, but we've got that little bit extra in there, which isn't what we want. We don't want anything left over. So we're going to exit out of that simulation. What we can do is if we go back in our toolpath, go into the Passes tab, we want to check this box here, roughing passes, and we want to say our maximum step over is, we're going to go 3 mil, and we want 2 step overs there, and we're going to press OK. And what that does is it allows the tool to travel around a couple of times, and hopefully what that allows us to do is remove that material on that wall. Now we've got a bit of an issue there where our material isn't getting out of our where our coin slot is. So what we're going to do is we're going to add that profile to our 2D adaptive. So if we go double click on our 2D adaptive, click on our geometry and just select that profile there, go OK, and then that's going to be added. But what we have to be careful is that we've got, if we double click on that, we've still got radial stock left over, so we have to come back and clean that up along with this wall here. So we're going to do that on the next toolpath. So we've got cleaning out this edge, we've got cleaning out this area in here, and now our next job is to remove all of the extra radial stock that we've got on the sides here. So we're going to use another toolpath in here. So I'm going to add another 2D contour. Tool by default, geometry. I'm going to select this wall. I'm going to select this edge here and then this edge. Now, doing this last 2D contour, you can see that it's only 3 mil, so we didn't have to be too concerned with the length of our flute, but these ones we do. So what we have to do in here, just like when we were doing the 2D adaptive, is we have to use multiple depths. Now because we're only taking off 0.5 of a mil on the wall, we can actually go deeper because it doesn't add as much stress onto our end mill or our cutter. So here I'm going to make a maximum roughing depth of 15 mil just for this operation because we're only taking off 0.5 of a mil of material, and then I'm going to go OK. So then we go and simulate it. No issues found. Cleans up those walls. Goes around. Cleans up. And makes those walls all nice. Now the reason we might do that is because when we're hogging out or removing as much material, we want to be quite fast and rough. With what this is doing is coming up and giving that wall a nice finish, so it looks all nice. Exit. Alright, so we've done 3 toolpaths. Alright, we've cleaned up all our walls. Now the next thing we need to do is actually cut out our letter. Alright, so what we're going to do is our final operation, and so for that we're going to be using another 2D contour. So we're going to select that. And again, our tool is default. We're going to move to our geometry tab and we're going to select this profile here. So when we click OK and we simulate it, we're going to have errors. Alright, you can see that it's dropping right down. So In order to avoid that, we need to double click and we need to use our multiple depths. And we're going to do a max of 6 mil. And then we can go OK. And then we can see it going down there. Our toolpaths. Simulate it again. And now we don't have any issues. Now, because we have to, we're actually like cutting a full slot, so it's full 6.35 mil. It adds extra pressure to our tool. So we just need to be aware of that when we're using clamps or our hold down methods, because it puts a lot more pressure onto our tool. Now, at that little starting point, you can see that the tool lifts up and down. That can take time away. So what we're going to do is we're going to change a couple of things. So I'm going to exit our simulation. We're going to go into here, go into our linking, and we want to select the keep down button here, keep tool down. We'll go OK. And we'll simulate it again. And then hopefully you don't get that movement, which it has done. Cool. Right, now when we cut something out like that, depending on how we're clamping it down, you can see here that there's a hole and there's nothing actually keeping our G attached to our stock material, which can have pretty disastrous effects if this G gets all loose when you've got a spinning end mill. So what we tend to do is add little connectors from our the thing that we're cutting out to our stock. That way everything stays in the correct place. So how we do that is we double click on our toolpath, we go to our geometry, we click on tabs, and you can see here you've got these little tabs that have turned up. I like to use triangular tabs because it has the tool has always got a forward movement, and I tend to change it from distance to number of tabs, and typically a good number is typically around like 4. You can also add manual ones as well. Some of the things can be in tricky places, but you can add extra ones in there if you like as well. When we go OK, our toolpath will change, and here if you look on the top, you'll be able to see all of the tabs in there, and that's just a bit of safety to make sure that all that time machining isn't going wasted by this rattling around and hitting the end mill while it's spinning before you're finished. Okay, so that there is all good to go in the sense of toolpaths, and the only bit that you have to do now is post-process it.